In this video, I will draw the acceleration time graph and the position time graph from the given velocity time graph. I begin with the acceleration time graph. I located my both graph underneath the velocity time graph, and I matched the time intervals exactly as I have them on the velocity time graph. So this means 10 goes under 10 minutes, 20 under 20, 30 under 30, 40 under 40, and so on. So let's look at the first 10 minutes of the motion. Velocity time graph shows me that the velocity is increasing at a constant rate, and the velocity is positive and the slope is positive. So it means that I have a positive acceleration. For the first 10 minutes, I have a positive acceleration, which is a constant acceleration, therefore it's a horizontal line. For the next 5 minutes, I have a constant velocity, which means I have zero acceleration, which I will show it on this line for zero acceleration. From 15 minutes to 40 minutes, I have a negative acceleration, which is shown in a negative slope right here, and it's a constant negative acceleration. So it looks like the slopes have about the same, have the same magnitude. So I would show the same value but negative as the horizontal line. From 40 to 55 minutes, I have a positive acceleration because it is a positive slope. However, the value of the slope, the magnitude of the acceleration, is lower than my initial acceleration. Therefore, I will draw it closer to the zero axis. Okay, so position time graph. From the velocity time graph, I do not know where my initial position is. However, I will assume that my initial position is at 0 at the time moment equals to 0. Therefore, I will start from the 0, from the origin. For the first 10 minutes, this is my 10 minutes, I know that I have a positive acceleration and my velocity increases. And my velocity is positive, so I'm moving in positive direction. So how can I figure out I know it's a parabola, but how can I figure out the shape of the parabola? So what helps usually is to figure out the dot diagrams. So I know my dot diagram should look something like this. It just increases, right? At equal amount of time. So this is my dot diagram. This is how I'm moving in positive direction on my position axis. So if I put these dots on this axis and I connect it with the equal time intervals, right? Equal time intervals right here. This goes here, and from this time interval it goes here, and from another equal time goes here. So I can see that the shape of my position time graph is the parabola of that shape. So I can draw it like this here. Next, from 10 to 15 minutes, I'm moving with constant velocity, but I'm still continue to move in positive direction. So it should go like this. It should be a straight sloped line. Then I still have positive velocity for all this period of time, from 15 minutes to 30 minutes. However, I am slowing down. So what is my motion diagram for slowing down. So I first have a great distance, then less, and then less. Okay, this is my motion diagram for x direction. And again, let's think, how would my parabola shape look like for the equal amount of time for the horizontal axis? All right, so if I connect this with this, then this with this, and this dot with the next one, and this dot with the next one. You see, so my shape should look like this. And it makes sense. Why? Because a tangent line at every moment of my time, right? The slope of this tangent line to the parabola will show what's happening to my velocity. For example, here the tangent line is like this. Here my tangent line, the slope decreases, and here it decreases even more. And it makes sense, it slows down. Similarly, with this parabola, my tangent line, the slope of my tangent line increases, and it makes sense because I'm speeding up. Therefore, my shape for the next from 15 to 30 minutes will look like that. I keep moving in positive direction until 30 minutes, but my velocity decreases. Okay, so here I change direction. At 30 minutes, I change direction. It means that for my position, I can start moving towards the origin. Okay, all this time I was moving away from the origin, right, in positive direction. At 30 minutes, I can start moving towards the origin in negative direction. So at 30 minutes, I still move with increasing velocity and negative acceleration. So I'm speeding up. I'm speeding up. Again, how does my shape look like? Let's do the dots. If I'm speeding up, it's like smaller, then greater, then greater. So it's similar like this, but it's in the other direction, right? So if you flip this parabola into the other direction, so until 40, I'm speeding up. It's right there, so it should look like this. Okay, at 40, what is happening? I started slowing down. I keep going in negative direction, so it means my position will change towards the origin, but I'm slowing down, which means that it has to look something like this. So this slope increases, the tangent slope decreases. So that is the position time graph for this kind of motion. Thank you for watching.